Dear students, in the previous presentation we discussed the important problems from the chapter Quantum Theory of Light. Let us discuss the remaining problems. The first problem is that the photoelectric work function of copper is 7.2 into 10 raised to minus 19 joule. Calculate the threshold wavelength. It is given that the speed of light c is 3 into 10 raised to 8 meter per second. Planck's constant h is 6.63 into 10 raised to minus 34 joule second. These are some useful equations for solving the problems. And in this problem, work function is given, that is phi equal to 7.2 into 10 raised to minus 19 joule. And it is required to calculate the threshold wavelength lambda 0. And as we have phi equal to h nu 0 is the threshold frequency. But it is required to calculate the threshold wavelength. Therefore, we have to rewrite the equation in terms of wavelength as hc by lambda 0. From this equation, we can calculate lambda 0 as lambda 0 equal to hc by phi. That is, just cross multiplying these two equations, we will get the threshold wavelength lambda 0 as hc by phi. H is given, c is given, phi is also given, and no need to convert the unit. The work function is given in joule. Therefore, we can substitute directly. This lambda 0 equal to hc by phi. H is 6.63 into 10 raised to minus 34 and c is 3 into 10 raised to 8. Phi is 7.2 into 10 raised to minus 9. And by solving this, we will get lambda 0 as 2.7625 into 10 raised to minus 7 meter. That is, adding these powers, we will get the power as 10 raised to minus 7. And this meter is the unit of wavelength. Then if we change the unit into nanometer, then we can write lambda 0 equal to 276.25 nanometer. Nano is 10 raised to minus 9. That is, this is the required threshold wavelength. Hope that it is clear. Now let us discuss the next problem. Radiation of wavelength 300 nanometer falls on a material of work function 2 electron volt. Calculate the maximum velocity of the ejected electrons. And it is given that the mass of electron is 9.1 into 10 raised to minus 31 kilogram. Planck's constant 6.63 into 10 raised to minus 34. Velocity of light 3 into 10 raised to 8 meter per second. Also given 1 electron volt equal to 1.6 into 10 raised to minus 19 joule. That is, we have to calculate the maximum velocity of ejected electron. And the given quantities are lambda, that is the wavelength of the incident radiation, 300 nanometer. So we have to convert it into meter, 300 into 10 raised to minus 9 meter. And phi is 2 electron volt. So to solve the problem, we have to convert the unit electron volt into joule. So we have 1 electron volt equal to 1.6 into 10 raised to minus 19 joule. Therefore, phi equal to 2 into 1.6 into 10 raised to minus 19 joule, which is equal to 3.2 into 10 raised to minus 19 joule. Okay. Now, let us calculate the maximum velocity of the ejected electrons. For this, we use this equation, V maximum equal to root of 2 into E minus phi by M. E is the energy of the photon and phi is the work function and M is the mass of the electron. Phi is given, M is also given, mass of electron, but E is not given directly. Therefore, we should calculate the value of E using the given data. And for calculating E, we have lambda. So, we have the relation between E and lambda is E equal to h nu, which is equal to hc by lambda. Then using this relation, we can calculate the energy of photon as 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 by lambda. Lambda is 300 nanometer. It is 300 into 10 raised to minus 9. Then we will get E as 6.63 into 10 raised to minus 19 joule. Okay. Now we have E, phi and M. So just substitute these values into this equation. We will get V maximum equal to 2 into 6.63 into 10 raised to minus 19, that is the value of E, minus 5. 5 is 3.2 into 10 raised to minus 19, and divided by M. M is given 9.1 into 10 raised to minus 31. Now, by solving these values, we will get the maximum velocity as 8.68 into 10 raised to 5. Don't forget to put the unit of velocity is meter per second. 8.68 into 10 raised to 5 meter per second. Since velocity is displacement by time, and the unit of displacement is meter and time is second. Therefore, unit of velocity is meter per second. Hope that you got this problem. And let us go to the next problem. That is, calculate wavelength of a photon if its energy is 4.48 into 10 raised to minus 19 joule. This question is very simple. Energy is given, and it is required to calculate the wavelength of the photon. So, we can use this relation E equal to hc by lambda. Okay, E is given, and we have to calculate lambda. So, we use the relation E equal to hc by lambda. From this relation, we can write lambda equal to hc by E. Okay, h is given, c is given, E is given. Now, need to convert. All the units are in SI. So, lambda equal to 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by E is given as 4.48 into 10 raised to minus 19. So, by solving these values, we will get lambda as 4.439 into 10 raised to minus 7 meter. So, in nanometer, we can rewrite this as 443.9 nanometer. Okay. And this part is not necessary, it is optional. You can stop here. If it is required to convert into nanometer, then you should convert. Okay. Then let us go to the next problem. Calculate the energy associated with photon corresponding to wavelength 400 nanometer. All are simple questions. Here again, wavelength is given, required to calculate energy associated with the photon. So, it looks like the previous problem. Here, lambda is given, we have to calculate E. Again, same equation, E equal to hc by lambda. And lambda is 400 nanometer. Nano means 10 raised to minus 9. That is 400 into 10 raised to minus 9 meter. So, E equal to h nu equal to hc by lambda. H is 6.63 into 10 raised to minus 34 joule second. And C is 3 into 10 raised to 8 meter per second. By substituting all these values into this equation, we will get E as 4.97 into 10 raised to minus 19 joule. Okay. In joule, its value is 4.97 into 10 raised to minus 19 joule. You can stop here. Then if it is required to convert into electron volt, then you can divide the value by the electronic charge. That is, the charge of electron is 1.6 into 10 raised to minus 19. So, then we will get the value of energy in electron volt unit. It is in electron volt, energy of photon is 3.106 electron volt. This is not required. If it is required, then you should convert it into electron volt. In the problem, it is not asked to convert. So, hope that it is clear. Then the next problem. The work function of a metal is 2.8 electron volt. What is its threshold wavelength? Again, simple question. Work function is given. It is required to calculate threshold wavelength. Okay. And what is work function? 2.8 electron volt. It is an electron volt. Therefore, we have to convert it into joule. Okay. Then, in order to convert into joule, we have to multiply the quantity with the electronic charge. That is 1.6 into 10 raised to minus 19. Then we will get its value as 4.48 into 10 raised to minus 19 joule. Now, the threshold wavelength lambda 0 can be calculated using the equation lambda 0 equal to hc by phi. Since phi is h nu 0 and nu 0 is nothing but it is c by lambda 0. So, lambda 0 can be calculated as hc by phi. Okay. Now, just substituting all the values, we will get the value of lambda 0 as 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by, and phi is 4.48 into 10 raised to minus 19. So by solving these values, we will get lambda 0 as 4.439 into 10 raised to minus 7 meter. And in nanometer, it is 443.9 nanometer. And this question is also very simple. Let us go to the next problem. When a metal is irradiated with light of wavelength 100 nanometer, the maximum kinetic energy of the liberated electron is 10 raised to minus 18 joule. Calculate the work function of the metal. It's required to calculate the work function of the metal. So, wavelength of the photon is given as 100 nanometer, that is 100 into 10 raised to minus 9 meter. And the maximum kinetic energy is given as 10 raised to minus 18 joule. And we have to calculate the work function. So, we have the Einstein photoelectric equation E equal to phi plus kinetic energy maximum. So, to calculate phi, can rearrange this equation as E minus kinetic energy maximum. And kinetic energy is given, is not given, but lambda is given. So, we can calculate E using the relation hc by lambda. And h is given, c is also given. So, E equal to h into c by lambda, that is 6.63 into 10 raised to minus 34 into 3 into 10 raised to 8 by 100 into 10 raised to minus 9. And by solving this, we will get E as 19.89 into 10 raised to minus 19 joule. So, kinetic energy is given as 10 raised to minus 18 joule and E is obtained in 10 raised to minus 19 joule. So, in order to minus E, kinetic energy from E, we can change the power as 10 raised to minus 18. So, 19.89 into 10 raised to minus 19 can be written as 1.989 into 10 raised to minus 18 joule. Now, we can substitute directly into this equation, that is work function phi equal to E minus kinetic energy maximum. And E is 1.989 into 10 raised to minus 19 minus kinetic energy is 10 raised to minus 18. So, now it is easy to solve. By solving this, we will get work function as 0.989 into 10 raised to minus 18 joule. We can rewrite it as 9.89 into 10 raised to minus 19 joule. Now we can stop here, and if required, we can convert it into electron volt. To convert into electron volt, we have to divide with the 1.6 into 10 raised to minus 19. Then we will get the work function in electron volt unit. In electron volt, phi is 6.18 electron volt. Okay. Now we solved almost all the problems in this part. So hope that all of you got all the problems, and hope that you can solve any other problems in this chapter. Thank you.